Okay, so just sketching in just a quick rough sketch of what we found so far. So theta was 0, r was 2, equates to the point 2, 0 in rectangular coordinates. Pi over 6, our radius was down to 1. And pi over 3, our radius was at a -1. Pi over 2, our radius was -2. So notice they're kind of a little bit all over the place. So we'll do a little bit of work with the calculator. Notice I'm in a different mode here. So in the mode key, you can go over to polar, as opposed to usually we're in function, once in a while in parametric. We are in polar at the moment. Go to your y equals, now it's an r equals. So r equals 2 cosine of 2 theta. The x key will default to theta in the polar coordinate version. And notice all of our action here was happening from -2 to 2. So I have it going through basically from 0 to 2 pi. And we'll narrow ourselves down here from -2 to 2 on the x's and the y's. And we basically end up with this nice, pretty little, as the name implies, rose curve. And we'll go over just some of the properties of the rose curve. Let's see, so we'll also talk slope and tangent lines. We'll finish the rose curves momentarily. So just like in our parametric days, dy dx is with respect to a different variable. So dy d theta over dx d theta. So horizontal tangent line basically means a slope of 0. That means the top was 0. Vertical tangent line then means we were dividing by 0. So for this one, dx d theta is 0. So for example, if we have an equation r equals 5 sine theta, 0 to pi, so theta is, of course, what we're referring to there. X is our cosine theta. Y is our sine theta. Well, r here is 5 sine theta, so then x is equal to 5 sine theta cosine theta. Y is 5 sine squared theta. So we replace r in each spot with the 5 sine theta. So a little more room to work with here. So let me just bring over the relevant stuff. X was 5 sine theta cosine theta. Y was 5 sine squared theta. So dx d theta, we're looking at a product rule. So derivative of the first factor would be then 5 cosine theta times keep the second factor of another cosine theta, so 5 cosine squared theta, plus keep the first factor, 5 sine theta, differentiate the second factor, which would be negative sine theta, so we can throw a negative on that and a square on that. So dx d theta is 5 by cosine squared theta minus sine squared theta. Dy d theta, you can just do the chain rule, so 5 by 2 is 10 sine to the first theta, or just sine theta, times derivative of sine is cosine. So if I'm looking for horizontal tangent lines, and remember we're on, theta is on the interval of 0 to pi, inclusive. HTL is just abbreviation for horizontal tangent line. Basically means my numerator was 0. We'll set this guy to 0. So 10 sine theta cosine theta equals 0. So where that's happening, anywhere that either sine theta or cosine theta is 0 on the interval from 0 to pi, well, sine of 0 is 0. Sine of pi is 0. And cosine is 0 at pi over 2, and it's not 0 again until 3 pi over 2, which is outside of our desired 0 to pi interval. So vertical tangent line, those happen when our denominator of dy dx is 0, so we want 5 times cosine squared theta minus sine squared theta to equal 0. So in other words, we want cosine squared theta to equal sine squared theta. Now those are happening at multiples of a 45-degree angle. So pi over 4, 3 pi over 4. So we skip over 2 pi over 4 because that's our pi over 2. Just picture your unit circle. So pi over 4, 2 pi over 4, 3 pi over 4. They have the opposite signs, but once we square them, that doesn't matter anymore. Now they're both positives. 4 pi over 4, 5 pi over 4, that's outside of the 0 to pi that we're working in. So they may ask us for some ordered pairs for these guys. So we'll start with the 0. If theta is 0, x is equal to 5 times sine of 0 cosine of 0 is 0. And y is 5 times sine squared of 0. Y is also equal to 0. So the origin has a horizontal tangent line. We had pi over 2 as well. Cosine of pi over 2 is 0, so x is 0. Sine of pi over 2 is 1. 1 squared is 1. 1 by 5 is 5. And we'll try out at pi as well. sine of pi is 0. Sine of pi is 0. Same point again, as far as the rectangular coordinates are concerned. Now that's if they wanted them in rectangular. If they wanted them in polar, we just used the relationship that r was 5 sine theta, and we can get them that way. So r equals 5 sine of 0. Sine of 0 is 0. R equals 0. So 0, 0 in rectangular or polar look the same. Theta equals pi over 2. R is 5 sine of pi over 2, which is 5. So radius of 5, theta of pi over 2. And at theta equals pi, radius is 5 sine of pi. Sine of pi is 0, so r equals 0. So 0 pi as well. Our vertical tangent lines, we work them pretty much the same way. Try out the pi over 4, and you know how to do the x and y. We'll just quickly run through the polar version. If you wanted rectangular, you can get rectangular very quickly and easily. So r equals 5 sine of pi over 4. Radius would be 5 root 2 over 2. So 5 root 2 over 2 with an angle of pi over 4. And r equals 5 sine of 3 pi over 4. Sine of 3 pi over 4 is the same as sine of pi over 4. So this is still 5 root 2 over 2. Just a different angle. All right, so we also want to look at tangent lines at the pole. Sort of a special property. F of alpha is 0 and f prime of alpha is non-zero. Then theta equals alpha is a tangent line at the pole to r equals f of theta. So for example, if r is 4 cosine of 3 theta, we'll call our r f of theta, so f of theta is 4 cosine of 3 theta. So f prime of theta then negative 12 sine of 3 theta. So we want places where f of theta is 0. So I want 4 cosine of 3 theta to equal 0. So cosine of 3 theta is 0. So at theta equals pi over 6. 3 pi over 6 is pi over 2, and the cosine of pi over 2 is 0. At pi over 2, 3 pi over 2, cosine is 0. And 5 pi over 6 turns into 5 pi over 2. And we're at 0. So the next we would try is 7 pi over 6, but that's equivalent to the pi over 6 that we already have. So if we try f prime at these angles, f prime of pi over 6, negative 12, sine of pi over 2 is non-zero. Sine of pi over 2 happens to be 1. Negative 12 is not 0. Same thing is true with the rest. F prime of pi over 2, negative 12, sine of 3 pi over 2. So that is a positive 12, which is also non-zero. F prime of 5 pi over 6, negative 12, sine of 5 pi over 2. So, quick unit circle here, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So that's a positive 1, so negative 12. Also non-zero. So those are the 3 tangent lines. All right, so I mentioned we'll do a little bit of work with the rose curves. We looked at one just in the calculator. There are some properties. N petals, if n is odd. 2n petals, if n is even, and at least 2. So for example, that last one, we had R was, if we have R equals A cosine n theta, the length would be A, and we would have, if n is odd, n petals, and the first petal starts on what would be equivalent to our x-axis. So this distance is 8 units. If r is a sine of n theta, we're starting up here also 8 units for each petal. It is possible to start down as well. So sine up and down, cosine left or right. That should not be super surprising. So this was an odd and even. R equals a cosine and theta. You'll have petals along horizontal and vertical axes. R equals a sine and theta. Your petals will not be across axes. So from that other page, we had R equals 4 cosine of 3 theta. So here n was odd, so that says we have 3 petals. It's a cosine. So the first petal is on here. And that is 4 units across. We'll pretend that I could draw those evenly spaced. And we have 3 petals, so they would be basically evenly spaced. So you'd have one down here, one up here. And we just kind of pretend that I could draw them the same size. And you can see that, so 4 cosine of 3 theta, and our window, we'll zoom it out a little bit. So -4 to 4, -4 to 4. So there is our nice pretty little rose curve. And our angles, tangent lines, we figured out tangent to the pole was happening at pi over 6, at pi over 2, and at 5 pi over 6. Okay, so the last little bit of homework to try out. Find the numbers here. So 10, 4, 1 to 5, odd. 11 to 15, odd. There were some other shapes that I sort of cut down on just for time's sake. 23 to 45, odd. 69, 71, 77. 81 to 85, odd, and 91. So if you have any questions, please get in touch with me. Otherwise, I'll see you next time.